wabarakatuh. My name is Naim Safwan bin Muhammad Nisham and we are from Group 19. Today, our group will present about the Torsional loading evaluation from actual structure, which is our group is using a tools that named Rachet for our research. Okay, then we go to the introduction of this project. Okay, torsion force is a twisting that is applied on an object by testing one end when the other is held in position or twist in the opposite direction. Okay, different material have different way of responding to torsion, which is some will deform, crack or break depending on the type and strength of the material. Okay, we go through to the objective of this project. Firstly, to draw details FBD from actual structure related problem. Secondly, to develop equilibrium equation from the FBD diagram. Okay, third, to analyze force member from the structure. Okay, then we go to the next part. Thank you.
Hello, my name is Assalamualaikum and for my part, I will explain about the part of Rachet. Okay, there are few important parts of Rachet, which one of them is the drive gear. Okay, drive gear is controlled by the lever, and first of all, we have to lock the lever in order to make it static and to make the pivot point smooth and not moving. Okay, after that, after we have locked the pivot, after we have got the pivot, and we use handle to force it clockwise in order to tighten the bolt, or we can also loosen the lever to and push anti-clockwise in order to loosen the bolt. Okay, after that, function of Rachet. A Rachet is a mechanical device that allows continuous linear or rotary motion in only one direction while preventing motion in the opposite direction. Rachets are widely used in machinery and tools. Okay, as I said before, a Rachet is mechanical device that allows continuous linear or rotary motion. Okay, for example, we want to tighten a bolt for a car or something that is mount, so we pivot it and we lock the lever and we put force clockwise in order to tighten it. Okay, in order to loosen it, we have to move the lever towards the bottom and we put force anti-clockwise and it will loosen the bolt. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nurul Faris bin Zawil Anwar. Now I will continue to the presentation. Okay, firstly I will explain about free body diagram for Rachet. Okay, look free body. Okay, for the first force that we put on the Rachet, we push the Rachet downward. Okay, next is distance. Distance means the length of the Rachet. Next is moment. Moment is force times distance. Okay, next is equilibrium equation for Rachet. Okay, sum of Fy is equal to 0. Force on y-axis is equal to 0. So all of the force on y-axis is equal to 0. Okay, sum of Fx is equal to 0. Force on x-axis is equal to 0 means all force on x-axis is equal to 0. Okay, the next is sum of moments is equal to 0. Moment is force multiplied by distance, which is all moments is equal to 0.
Okay. My name is Assalamualaikum and I am going to explain about the analysis and discussion about our model is Rachet. Okay, this is the Rachet wrench and this is the nut. So the pivot point is we plug in this this thing by pressing the button here. Into the hole. Okay, so there it is. So if we place this head towards the screw, and this is gonna be the pivot point, which the force acting on this area is 90 degree, which will not moving. And after that, we press the handle anti-clockwise. Okay, before that, I'm going to show this one. This is the lever which control the moving or rotation, whether it will rotate anti-clockwise or clockwise rotation. Okay, for example, if we place the lever like this, the ratchet, we can rotate it clockwise. Okay. And if we move this lever downwards, we cannot move it clockwise anymore, because the pivot point change and the rotational will move anti-clockwise. Okay, for example, if we plug in the screw here, so the pivot point is static, we cannot move anymore. Okay, we for example, we put force downward here, for example 180 Newton. Okay, then we try to move. Okay, so if we move it, if we put the maximum force, the screw here will break. By doing that, we can calculate the maximum force that the material can withstand.
Okay, next is factor of safety in ratchet. Okay, you can look at the slide. Okay, equation of equilibrium. So equation is I just present before this. Okay, now I put the force in Fy is equal to force in Fy is 200 Newton, and the distance is 0.16 meter. 200 times 0.6 minus T. T means stop. So 32 Newton meter. Okay, the before that I will show the data that has given. Length is 0.16 meter. C is 0.02 meter. Weight is 500 gram. Force is 200 Newton, and G is 78 gigapascal. Okay, next we look at the angle. Before that, we look at the polar moment of inertia. Polar moment of inertia is, the formula is J is equal to pi over 2 times C powered of 4. Pi over 2, and we have got the C is 0.02 powered of 4. So the answer is 2.513 times 10 exponent negative 7 meter powered of 4. Okay, next we can find the angle of twist. The formula is TL, L for length, T is that we got from equation of equilibrium, over J. J is polar moment, and G has given 32 times 0.16 and divide by 2.513 that we got from polar, and times 78 times 10 exponent 9. Okay, the answer we got is 2.6121 times 10 exponent negative 4 is in radian, but we want in degree. We must times 180 and divide by pi. So we got 0.015 degree. It is small because of the minimum angle that we push for the ratchet. Okay, next is shear stress. Okay, firstly we must find the internal. Internal torque is equal to 2 times T. T we got from the moment that we are before this is equal to 64 Newton. And next is torque allow. Torque allow, the formula is torque times C over J. J is polar. Okay, we got from the torque allow 2.5468 megapascal. And next is torque maximum. The formula is T. Torque internal. 64 times 0.02 divided by J, polar moment. The answer is 5.0935 megapascal. Okay, for the last, we must find the factor of safety, FOS. T max. Torque max, the formula is torque max divided by torque allow. So the answer we got is 1.9. So 1.9 is mean factor of safety 1.5 to 2. The application for use with reliable material where looking and environmental conditions are not served. So the FOS are suitable with this structure. So that's all for me. Thank you.
Okay. For the discussion, our group have chosen Rachet as our model for this project because this model is reliable as well as efficient to be used in engineering industry. On top of that, Rachet wrench is very useful to help technical personnel to tighten or loosen the bolt, which is requires not that much force as the handle of the ratchet is large enough. Okay, then the pivot point of the ratchet is very strong in order to prevent the surface of the material that has been locked from failure. Okay, we go to the conclusion. Okay, we go through to the final part of this presentation, which is a conclusion. Okay, for conclusion from our project, we can conclude that the model of product that we have chosen to study the torsional loading evaluation is Rachet. Okay, second, we have determined the behavior under the torsional force, which when the torque is applied to the structure, it will create twists along the road. Okay, lastly, we have calculated that to avoid failure of the shaft, the maximum shear strain must be below 4.6443 kN. That's all for our group. Thank you.